Last section we started with chapter 7, which is about Laplace transform. Can we go through the material that we explained and try to recall some of the ideas, the main ideas? So what do we know so far from the Laplace transform?
It works on the
Initial value problem that they are defined as zero and they should be linear. Okay, this is the application of it, but let's say the Laplace transform is defined as what? So the Laplace, I would say, is defined as well the plus of f of t.
which we change on the usual.
Yeah, so that's something I want to apply. Laplace, I'm telling you find Laplace of f. What do you do? I'm giving you a function. Formulas, and if the formulas don't work, what will you do? Integration from 0 to infinity, and you will multiply it by e minus f. So the new function will be in terms of what? In terms of so Laplace transform means that we are transforming instead of the variable t, which is called non-negative, we are transforming to another variable f, which is also non-negative. Now the application as a is the importance of Laplace transform in this course is to apply that is called initial value problem. We talked about more than one formula, and then these formulas, if we have it in the form of Laplace, we have it also in the form of inverse Laplace. For example, if I'm asking you what's the Laplace of phi, phi is considered as what? Constant. So what would be the Laplace of it? Pi over s. If we have Laplace of t power 5, we will compare it with which formula? And so instead I will write 5, we'll get 5 factorial over s power 5 plus 1, which is s power 6. Okay, so in order to understand this lecture, we need the formulas from the previous lecture, which are for Laplace and inverse Laplace. We are still in the last learning outcome, and our main objective today is to know a new formula and apply it. Now, why do we need a new formula? In order to deal with more or with different function. Right. So we will first start with translation formula 1. We'll talk about the part of it as Laplace and the part of it as inverse Laplace. Whenever we have Laplace, we have another formula in inverse Laplace, and that will apply this formula to other ones. Now, let's look at this one. Suppose that I'm telling you find Laplace t e power 3t, or I'm asking you to find Laplace of e negative 5t times 3t. What's the common between these two functions? Exponential. If we remove the exponential, do we know the Laplace? Let's say I don't have the pink part. Can I find Laplace of t, which is 1 over s squared? And the second one, Laplace of sine 3t, do we know it? So our problem is in the exponential. So our aim for today is to solve Laplace for something e80 multiplied by a function that we know is Laplace. So let's say I have t power 100 multiplied by e power. I have cosine 70 multiplied by e power negative 90. The formula is very easy. Let's look at it. So first of all, Let's say I have Laplace E3. Let's compare it to here. What's our app? What's our? This one, from this one, what can we get? Our? Okay, we are saying f of f minus a. So this one, it would be cap f minus. In order to find this one, we need to find Laplace f of s. What's f of s? It's Laplace of the function alone. So Laplace of t. What's Laplace of t, miss? 1 over s squared. Do agree with Abdurrahman that it's 1 over s squared? Now, what do you mean by f of f minus 3? Miss, when we say f of t equal t plus 1, let's say f of 0 instead of t, what are we putting, miss? T equal 0. F of 3, t equal 3. F of f, t equal f. So here, f of f minus 3 means that we are putting instead of f minus. So this will be the answer for this one. Please write it down. We will apply this on more than one question, and then we will move to the inverse Laplace in order to apply it to differential.
You like what is involved or not?
The formula is up. Here I'm just applying the formula, direct application for the formula. This one we call a translation theorem or translation formula 1. We'll still have the other translation formula.
Translation formula. Translation formula.
Already I added here some questions, but we can always construct our own question. So here we have 2 examples that we already solved. Let's do our own examples here. So let's choose the first one. Laplace of e negative 3t sine 7t. We need to find this one, and we need to find Laplace of et sine 40. Can you start with these ones, Mas? Here, Miss, what's the form of f? This is our f of t, right? So we will write first f of t equal sine 7. Go back to your table. What's the Laplace of sine 17? So f of f E 7 over x square plus 7. Right, miss? We wrote it. Now, what's our A? This one is our A. Laplace of this one is f of x minus A, f of x minus. So what will we get here, miss? Of x plus 3. Please stop writing a little bit because you will do the second one alone. We will substitute 7, it says that square, I will keep it as something, square plus 7 square is 14. Now, if f of s 7x squared, f of s plus 3 instead of s, what will we put? S. Do we need to expand? No. We keep it in space. Let me sharpen this from the board. Please do the next one to make sure that everything is okay. Always miss the Laplace is straightforward. The thing that needs more work is the inverse Laplace. So this is the one that requires more work. Because you need to apply the class inverse. Means that you're applying the class and getting these ones, then you will apply the class inverse. Now, the more questions that we have in the exam, the better, because you will not lose lots of points. So we have 3 pathways. Basically, each of these topics, they should have 10 points. Now, maybe Laplace, because we needed more time for it, maybe Laplace will be like 12 points, and the other ones will be 9. But anyways, I will let you know the weight of each chapter. Laplace, it needs more work and more study. So, and we'll have, logically, we should have more questions about. Okay, the second one, what's our f of t and what's our a? So what will we highlight? We'll highlight what we have here. We will highlight what we have here. Who will tell us what's our f of t? Cosine 4. So this one is f. And what's our a? A is 1. Okay, what's our f of f? Plus cosine 40. K here is 4. What do we put up? We put k or f? F over f squared plus 4 squared. So this one, it will be f of f minus a, which is f of f minus 1. Okay. Instead of f that is here, we put, okay, and here, square plus 60. No need to expand this. We will do one more to make sure that everything is okay, and then we will move to talk about the inverse Laplace formula. Any questions, Max? Do we have questions? Let's do this one. Do this example in order to move to the next idea. So Laplace, when we have a constant, this constant, we put it outside, right? What's the first step? Laplace of t 99 e negative t, and here this one, Laplace of I radical 2. This one that is here, miss, is a constant. What's the Laplace of the constant after? Constant over s. What will we get here after that one? So this one, we are done with it. Now the second one, let's analyze it. What's our A and what's our F? So A is -1 and our F of t is t power 90. Okay, please continue this part, please. What's our F of S? Okay, what's this one? 99? Right? So what will be this one? 3 and 99 factorial stays the same. Power 100, it stays the same, but we will put s minus minus 1, which is s plus 1, and this one we've copied the same. So it will be 5 and 2 over. This will be our final answer. Do we have the question? No. Laplace of EAT f of t is equal to f of s minus a. So Laplace inverse of s minus a, it will be EAT f, right? Let's look at this one. Laplace of t e power 3 is 1 over minus 3 squared, right? So what can we deduce here? Laplace inverse 1 over s minus 3 squared is e 3t. It's not writing it. No. If I did not make this one, how can I know immediately by seeing this one that this is TE 3T? This one, remove the negative 3. It comes as what? 1 over s squared. 1 over s squared, the Laplace inverse of it is what? T. But here I have -3. It means that A is equal to what? So I will multiply it by E3. Okay, let's please take your notes to start with our examples. Oh. Let's think about this one to make sure that everything is okay. Last and third. Oh. Think about this one. Again, when you have instead of S plus something or S minus something, cover it and check it alone as well. Let's take a few minutes to think about this example. Okay. We don't have this plus 8. What would we get? The plus input of 1 over S 101. This one using the table. This is the before S and plus. This is the before. And plus 1 means that and equal 100. So it is 1 over and factorial e power n, right?
Yes.
Which is 100 factorial, and this is e power. This one we call it f of t. Okay. Now this one it should be what? A equal minus. So if we have s minus 8, a equal 8. And if we have s plus 8, a equal -8. Okay, miss? So what will we get? All that we need to do is multiply it. And this will be our final answer. Okay, miss? Is it clear? Did we finish writing from the board? Okay, let's look at the example now. As example. Okay, just as a, we cannot have S and S plus 2 at the same time. All of them should be inside. Okay, so here I have S plus 2. And here I have only S. So this S, it should be S plus. Now, how can we make the S as S plus 2? I mean, add minus, so I got the plus. So this is the first step that you do. Laplace inverse at plus 2 minus 2 over 5 plus square 9. And this one, how can we write it now? We will get Laplace at plus 2 over at plus 2 square plus 9 minus 2 Laplace inverse 1 over minus 2 Laplace inverse 1 over f 2 square plus. Right, miss? Okay, now for the first one and the second one, if we remove the 2, they remind us of what? The first one, it will remind us of
Sine 380.
cosine 3t, and the second one of
Sine.
sine 3t or sine 3t over 3. In sine, we have k up, right? Please write this one down, continue it, and we will discuss what happens. Any questions till now, miss? So we need the first one and the second one. Laplace inverse of the first. So Laplace inverse at plus 2 over at square plus 9. We remove the 2, miss. We are left with what? We are left with cosine 3. And this plus 2, it means that 8 equal. So we will multiply by this. Any questions, miss? The second one, Laplace inverse of 1 over at plus 2 square plus 9. We will remove the plus 2. This one, it reminds us of sine, but 3t. When we have sine, it means that sine or shine will be 2. We divide, and this 2 be negative 2t. With each of them alone. Now you should combine them. You will combine now to find an answer. First minus 2 the second, exactly. Do you have any questions? Let's think about this slide. Any questions before we proceed? Do we have any question? Oh, Laplace inverse of 1. Write this question. Think about it for a few minutes and then we will discuss. Laplace inverse which reminds us of what? Integrals, right? If you have such an integral, how does it work? From calculus to math, if we have such integral, we have something known as completing square. And my students at calculus, I will explain it like that for that, right? So if we have a square plus ab, how do we complete the square? And a square minus ab, how do we complete the square? A square plus ab is a plus b over 2 square minus b over 2 square. And this one is a minus b over 2 square minus b over 2 square. Write these ones. Try to use them in the next exercise to solve it or to find the inverse of class.